Hello everyone, and welcome to this video where we will do a little function analysis. A beautiful exercise, and I'm very excited about this one. So we will be looking at this function right here. And we will start by finding its domain. So by looking at the denominator, we can clearly see that x cannot be equal to 4. And from looking at this uh, expression right here, recall that x has to be greater to or equal to 0. So the total is x is greater to or equal to 0, smaller than 4, or x is greater than 4, and this is our domain. Moving on to finding our intercepts. So let's see what happens when x is 0. When x is 0, the numerator of the function is 0. The denominator is minus 4. So in total, y is 0. And obviously, the same happens finding out the where y zeroes out. It happens where the numerator zeroes out, and that is, of course, when x is equal 0. So the intercepts are 0, 0. Okay, so we have this right here, and we have our domain right here. Let's see if we can find any type of symmetry for this function. So by looking at the denominator, we see that we have x. It is not, there's no even power over here. So substituting negative values or positive values will result in different values in the denominator, but also recalling that the domain restricts us from actually substituting negative values, so we conclude that there is no special symmetry around the y-axis. We can find other types of symmetry, but I'm not going to go into that one right now. Let's see if we can find any asymptotes. Okay, asymptotes. So let's start by checking out what happens if x approaches infinity. If x approaches infinity, the numerator still looks like this, but the denominator becomes x, and substituting very large values for x, you'll see that the denominator is much larger than numerator, thus approaching to 0. Okay, so this is the horizontal one. Let's see if we can find a vertical one. So the only suspect for a vertical asymptote is the value x equals 4. So let's see what happens to our function as it approaches 4. We cannot substitute the exactly 4 because the denominator will become 0. So let's see what happens if we just approach 4. So if we approach 4, the numerator can be thought of as exactly 4 because, for example, looking at 4.000000001, we can roughly say that it's negligible and it's exactly 4. Then we can look at this thing and instead of x, write 4 plus some epsilon, a very small value, minus 4. So I've substituted a value that is infinitely close to 4. We are left with this thing right here. And as epsilon becomes smaller and smaller as it approaches 0, it is very small compared to the numerator. So it all approaches infinity. This is what happens if we look at a value slightly larger than 4. What happens if we look at a value slightly smaller than 4? We can express it as 4 minus some epsilon. Okay, so we will be left with something similar, something looking like this. And this time, as epsilon becomes infinitely small but negative, this right here approaches minus infinity. Okay, so we have the general idea that as we approach 4 from the right, we approach infinity, and as we approach it from the left, we approach minus infinity. So I thought that was a beautiful way of looking at this thing. And let's move on to see if we have any critical points, if we have increasing, decreasing intervals. Let's see what's that all about. So critical points and increasing and decreasing intervals. And for this, we have no other option but to find the derivative of this beautiful function. Recall that if we derive something looking like f over g, let's write this more neatly. F over g, the derivative of this is f prime g minus f g prime divided by g to the power of 2, and that's exactly what we're going to be doing next. So f is x to the power of 2/3 and g is x minus 4. So the derivative is 2/3 x minus 1/3, that's f prime, times g, which is x minus 4, and then minus f untouched times the derivative of x minus 4, which is 1. So this is the numerator divided by g to the power of 2, which is this thing right here. Let's see if we can zero this thing out. Or rather, you know what? Let's simplify this a bit before we go on. So simplifying this, we get x to the power of 2/3 minus 8/3 to the power of minus 1/3 minus x power of 2/3, the denominator, sorry, remains the same. Simplifying this, we get minus third x to the power of 2/3 minus 8/3, so power of minus 3. The denominator remains the same. Let's see what happens if we try to zero this out. So we will be looking at the numerator. We don't care at this point about the denominator because it won't help us zero out the function. So we're looking at minus third x to the power of 2/3 minus 8/3 x to the power of minus 1/3. We're trying to zero this one out. Let's multiply this by 3. We don't want this fraction right here. Let's multiply this also by x to the power of 1/3 to get rid of this thing, and we will be left with minus x minus 8. Beautiful. So what we're getting is that x equals minus 8. Okay, this is outside of the function's domain, so no critical points. Let's write this down. Okay, but let's look at the sign of this derivative of y prime, because it will tell us if the function is increasing or decreasing and y points. So at what intervals? The denominator of y prime, denominator is always positive, okay, or 0, but basically it's positive except for the where it's not defined. Denominator, and the numerator is, except for the parts where it's 0, which is outside our domain, is is negative, because this thing right here in our domain, it's also is always positive. The x to the power is always positive. Multiplied by a negative number, it's negative. So it is always negative, which means it is always decreasing. Okay, so we already know quite a bit about this function. I think it's safe to say that we know enough to be able to make a pretty good sketch of it. Okay, so let's take the x-axis, let's take the y-axis. I'm not leaving a lot of room for the negative part because we know it is not defined over there. So we have a function that's always decreasing, something like that. It's always decreasing. Its intercepts, the intercept is simply 0, comma 0. Then it decreases until 4, until x equals 4. But as we approach 4 from the left, the value of the function approaches minus infinity, so it's going to look something like this. Okay, approaching infinity. And then as we move away from 4, we can see that as we approach 4 from the right, we're getting closer to infinity. But as we are moving away from 4, we're approaching 0. So our function actually is going to look something like this. Beautiful. I hope you enjoyed this video. I hope to see you again on my channel. I wish you a very, very pleasant day.